Okay, so here we have an RL circuit, resistance there in series with inductance. Your L has got a value of 0.2 henries, but you don't know how many ohms this is generating and contributing to the circuit. And you've got a resistor here and it's got a value of 50 ohms. The supply in the circuit is 240 volts at 50 hertz. The first thing you're asked to work out is the impedance. So in order to make a start in doing that, we're going to work out first what the inductive reactance is. How many ohms in that circuit are due to that inductor? And your formula for XL equals 2 pi FL. So it's 2 times pi times F is the frequency of the supply, that 50 hertz, times L, the value of that inductor, the 0.2. So in your calculator, 2 times pi times 50 times L. If your calculator's like mine and it's set up for maths mode, you just press standard to decimal, and that puts it into a decimal number. Now you're not asked for XL in the question, you're asked for Z. So in order to do that, I'm going to sketch an impedance phasor diagram. So for my impedance phasor diagram, I'm going to first sketch out the structure of my diagram, and I'm going to select my scale. The bigger you draw your diagram, the more accurate your readings are going to be. So that's for my impedance phasor diagram. And for my impedance phasor diagram, I'm going to decide that 1 centimetre would be equal to 10 ohms. So looking back there at your resistor's 50 ohms, so that's going to be 5 centimetres, and your resistance always goes out that way to the right. So always on this axis, the only thing that will change about it will be the length of the phasor. So there it is out to there. Try this one. That's my resistance there, my 50 ohms. My XL, 62.83. That goes in the vertical axis. And again, scaled, it would be 6.283. And that's my XL. So my R was 50 ohms. My XL, 62.83 ohms. So to get my Z, it's the phasor addition of these two. So usually the easiest way is to draw a vertical dotted line up from the end of the R, a horizontal dotted line from the end of XL, and the intersection of that will give you your Z phasor. Your Z is your phasor addition of R plus XL, so it's as if you've taken that XL phasor and put it on the end of the R phasor. So you're adding them the same as you add vectors nose to tail. So measuring this, that would be your circuit phase angle in here as well. So having a look by measurement first, by measurement, my Z is about 8.1 centimetres. So by my scale, if 1 centimetre equals 10 ohms, then that is about 81 ohms. We'll be able to confirm this by calculation. For my angle, using my protractor, my circuit phase angle, I think, looking here, counting round, 10, 20, 30, 40, 50. I think it's more like 51 degrees. So that's what these would be by measurement. And that's my impedance phasor diagram. Now I'm going to look at what this would be by calculation. So you can see from the values here that this is a right-angled Pythagoras triangle. So the square of the hypotenuse would be equal to the square of the two sides. I'll do it down here by calculation, and then you can see the both. So by calculation, you would expect z squared to be equal to r squared plus xl squared. So z equals the square root of r squared plus xl squared to the square root of 50 squared, I'll put this in brackets, plus 62.83 squared. So on my calculator, the square root of 50 squared plus 62.83 squared. And I'm getting 80 point, rounded to four significant figures, 80.29 rounds up to 30. So that's 80.30 ohms, which is very similar to that 81. That's probably about as good as I could measure. And my angle, using SOHCAHTOA, I've got the values of the opposite and the adjacent. So I'm going to use tan. Tan of the angle equals the opposite, which is my XL, over my adjacent, which is R. And for every circuit, you could use this same formula. You don't have to go back to first principles and look at SOHCAHTOA again. So to get my angle, and do that. Shift tan 62.83 divided by 50. Make sure your calculator's in degrees with a wee d up there. And I've got 51.49 degrees. Again, very similar to that. And that's my circuit phase angle. That's my circuit phase angle by calculation. That's my circuit phase angle by measurement. That's my impedance by calculation. That's my impedance by measurement. So taking those values, I'll take all the ones from my calculation. My Z was 80.30 ohms. My circuit phase angle, 51.49 degrees. The next thing you're asked to work out is the supply current, this current here. Previously, you'd have done I equals V over R, but because it's an AC circuit, it's I equals V over Z. So take the magnitude, the size of the voltage, 240, and divide it by the size of the impedance, the 80.30. Again, convert it into a decimal. That wee dot means a repeater. So press it again. And round it to four significant figures. It all rounds up. And I really get 2.99. So 2.99 amps. The next thing you're asked for is the voltage across the inductor and the voltage across the resistor. So we'll do the voltage across the resistor first. VR equals I times R. So 2.99 multiplied by the 50. So 149.5 volts. And VL is I times XL. So it's 2.99 times 62.83. And that gets you 187.86. Now you wouldn't expect these two to add up to give you this supply voltage because they don't add up just arithmetically like this. You have to add them like phasors on a phasor diagram, which should look very similar to this impedance diagram, but the sizing will be different. So what we're now going to do is we're going to draw the phasor diagram. So again, this will be the phasor diagram. The phasor diagram should just have voltages and currents on it. And voltages and currents will be on different scales. Voltages tend to be quite large, currents will be quite small. So you have to think of a scale for your voltage, think of a scale for your current. We've only got one current, so we might just do that one first. And your current is your 2.99. So for my current, I'll say 1 centimetre equals 1 amp. Current is in phase with resistance. So if resistance goes this way, current will go this way as well. So I'll follow that. I'll use that. Use this to make it a bit more visible. That's my current phasor. And then I have to think of a scale that's going to suit for all the voltages that I've got there. So the voltages I'm looking at, 240, 187.86 and 149.5. So for my voltage, I think I'll say 1 centimetre is 60 volts. I think I'll go for that. So 1 centimetre equals 60 volts. So the first voltage I want to do is that 149.5. So to work out what that's going to be in centimetres, I'm going to divide it by my scale of 60. So 2.49 centimetres. I'll maybe change my scale. I'll make it a scale of 30. So it's 149.5 divided by 30. Because I don't want my diagram to be too small. So I've got 4.983 repeater. So as well, the best I can draw that will probably be the 5. That's my voltage across my resistor. The voltage across my inductor was 187.86. So I'm going to divide that by 30 on from my scale as well. And that gets me 6.26. So looking at that. If I'd made it smaller, it would be less accurate. That's my voltage across my inductor. And the same as I did in my impedance phasor diagram, I'm now going to sketch out from these 2 points. So I'm going to sketch up vertically from here. Horizontally out from here. In the phasor addition of VR and VL, it's a series circuit, you should be able to add them up and get your supply voltage. And when I measure that on my scale, I'm getting that to be 8 centimetres. By measurement, my voltage is 8 centimetres, and using my scale, 8 centimetres times 30, 8 times 30 gets me 240. And 240 ties in with the voltage I've got here. The other thing I can put in this diagram is my circuit phase angle. Your circuit phase angle is really the angle between the current and the voltage. But it should be the same on this diagram as it was in this impedance diagram. So by measurement again, I'm going to get the circuit phase angle. And I'm going to get that with my protractor. So measure it here. Let's have a look. It's about 51 degrees again. And again, that should tie in with my phase angle here. So that's that question completed. That's all my calculations with my impedance phasor diagram and my phasor diagram.